Welcome to week 3. This week we're going to be learning the Pythagorean theorem, and we're going to be using a couple formulas that we've already learned for area of a triangle and area of a parallelogram to solve for a missing piece of information. So if you recall, the formula for area of a triangle, the area of a triangle is the base times the height, and then we divide the answer by 2. That's the easiest way to look at it. So this example says is if this whole triangle is 18 inches squared, so that we're saying that the area of this triangle is 18 inches squared, what is the height? So we have a formula. We've been given the area and we've been given the base, but we're looking for the height. So if you look over here, if we substitute all that information in, 18 is equal to 6 times the height divided by 2. And if we take 6 divided by 2, we get 3. And if we divide both sides by 3, we get the height has to be 6. And an easy way to check that would be the area is going to be 6 times 6 divided by 2. And that's going to be half of 36, which is 18 inches squared, right? So that's using our formula to solve for a missing variable. So let's try this example down here. In this example, you're being asked to find the area of the shaded region. So the area of the shaded region in this case it's hard to see here, but it's actually this triangle here. So we're being asked to find the area of this triangle. Well, we don't have a way of finding that area because we don't know its height. Its height is always vertical, but we do have two triangles that we can find the area of. So if you think about it, if I find the area of this big triangle and I take out the area of this little triangle or the medium-sized triangle, if I subtract those, I'll have the area of this outside triangle, right? So what's the area of the big triangle? The area of the big triangle, the base of the big triangle is 9 and the height is 8. So we'll say the area of the big is going to be equal to 8 times 9 divided by 2. And if you multiply 9 times 8, you're going to get 72, and 72 divided by 2 is 36. Okay, so that's the area of the big triangle. If we want the area of the medium triangle, that's going to be 8 times 5 divided by 2. And that's 40 divided by 2, which is just 20. So that means this whole big triangle is 36. This whole thing is 36. And this part here is 20. So what part has to go in the shaded part? Well, 20 from 36 leaves me with 16. So this one has to be 16. So we're not able to have found that using a formula because to find the area of that slanted triangle, we'd have to know its, well, I guess we could know its height. Its height was really 8. You actually could have done it the other way. So let me show you. This height here of 8 is actually the height of this triangle as well. So if we had moved this over, we could have said this is 8 times 4 divided by 2, which is 32 divided by 2, which is also 16. It's another way you can get it, right? But I found it easier just to use the difference between these two triangles. All right, moving on to area of a parallelogram. So in this case, to find the area of this parallelogram, we need to know the area of its base times its height. So, or the length of we multiply base times height. So in this case, area is base times height. So the base is pretty easy. We just have to count. So if we look, this base is going to be from 0 back to -6. So we know that that's going to be 6 units long. Length doesn't matter the direction, so we know that's 6. Now the height, this, we'd be tempted to use this as the height, but the height is always vertical, right? And we're pretty lucky here because the height is right there along the y-axis, so we can just count from -4 all the way up to +4, and if we add those together, we get a height of 8. right? So this distance here is 8. And if we just multiply 8 times 6, I'm sorry, we don't divide by 2. We just multiply 8 times 6, we're going to get 48. And we don't know the units here, so I'm just going to put units squared because there are some sort of square units here. And so this shape, it is a parallelogram. We can't find its area unless we have a perpendicular line to the base, and this perpendicular here is, in this case, the y-axis. All right, so that's using the area formulas of the triangle and the parallelogram. So we're going to move on to the Pythagorean theorem in the next video, and we'll be using Pythagorean theorem for the rest of this lesson.